Hello guys, this is Saddam Leonardo Cap. Welcome to my channel for Just for Fun. In this video, I'm going to talk about spherical polar coordinate system. As you have seen my previous video where I have discussed about polar coordinate system and Cartesian coordinate system, because as we have different kind of symmetrical, just like suppose you have cylinder or a spherical object, so you cannot always use Cartesian coordinate system. Well, you can use, but what happens is that your life becomes too much complicated. So as our symmetry gets altered, we will use different kind of different kind of coordinate system for different kind of symmetries. So for spherical symmetry, you can guess that we can use spherical polar coordinate system. To do that, the idea is that you have to locate how you locate any kind of point at a sphere, because you have a spherical coordinate system. So you need to understand if you are in Earth, how you determine that what is your location. So in surface of the Earth, what you are going to do is that you are simply locating your latitude and longitude. Okay, now that's the same thing we are going to do. So to understand that how we can find the longitude and latitude, we first have to understand that how we are doing everything in Cartesian coordinate system. So I have also discussed this in my previous video. I am discussing now again that if you have some kind of point P, then we can easily express in terms of x, y, z. Okay, so now what we're going to do is that if I am having any point on the surface or anywhere in the sphere, what I am going to express in terms of r, theta and phi. Like x, y, z, we have three parameters, that is called radial parameters, another is called latitude, and one is called longitude. So what is the theta, what is r, what is theta and phi? Suppose I am having some kind of suppose this is my center, and parallel to this, because we can see that this is the center, use that. Suppose this is my origin, and parallel to this is my z-axis, this is my x-axis, and this is my y-axis. Now I want to find what is, suppose I am having some kind of point P here, what is my r, theta and phi. So well, from here my radial distance is like this. Now since we are in the surface of Earth, if we are living in the Earth, we are in the surface of the Earth, so there is nothing that we can go inside Earth and so on. So we are just needed only longitude and latitude. But for mathematical simplicity, or for mathematical purpose, what happens is that we can go anywhere in this sphere. So we need this radial coordinate. So radial is simply varying from how we are far from the center, and the angle that is making it from this kind of theta. So if you are having a north pole like this here, so where are you from the north pole? Okay, and simply that I have to draw a perpendicular in the plane of x, y. So suppose this is my x and y plane. So I have drawn the point, I have drawn a perpendicular from this point, and now I'm going to join this from here. Okay, like this. Suppose this is a plane, and I'm going to join like this here. Now this is making an angle phi from this guy. So you can see that I am having now r, theta and phi, so I can easily express here it's my r, theta and phi. Well, here I am having this version that x, y, z. I am using this coordinate system, Cartesian coordinate system, as a reference frame for this spherical system. Okay, suppose what I am going to do is that from here to here the point is my r, and from this guy to this one, let's suppose this is my rho. So let's make parallel to y-axis and then parallel to x-axis for here. The simple fact is that suppose you are having any kind of point here, what happens, what you are going to do is, suppose this is my rho and this is my making an angle phi, x and y. So I can take a component parallel to y-axis, and this is parallel to x-axis. So this is nothing but rho of sine phi, and this is of rho of cos phi. You can easily break this component with the help of cosines of phi and sines of phi. And I can express this kind of vector. Rho vector is nothing but rho of sine phi y hat, rho of cos phi x hat. Okay. Now what I'm going to do is that, suppose you have having having any kind of vector, so the increasing direction of this vector will give you this magnitude. So if this is my rho, I can easily express this is my rho hat. Now phi, the phi is making an angle, phi is making an angle from x-axis. So if I am going this way, so phi is my increasing angle. So this is way we can increase this phi. Now theta is making from this side, so I can go here to here and my theta will be increasing. And if I and the r hat is going to like this, so r hat, theta hat, and I can easily express here phi hat. And these whole guys r theta and phi, they are mutually perpendicular to each other. Okay, well, what I am going to do now is I have to figure out what's my r vector. This is my r vector, this is my rho vector, and this is my z vector, because from here I am going to this one. Now first let me just break this component r vector in terms of z and this one. Now this vector is not parallel to y-axis, but it is parallel to rho vector. Okay, because it's my perpendicular to this one. The perpendicular from here to here is like this. So I can break this component in the fashion of r cos theta z hat r sin theta. Well, I don't say, I say via rho hat. I can write it as. So this vector, or this the length of this arrow and length of this arrow is same. So I can write is rho is equal to r of sin theta. Now what I am going to do is that I am going to use the triangle law, because you can see that now r vector can be written as this vector plus this vector. Now what I am going to do is I can write r vector in terms of OA vector plus AP vector. OA vector is going to give me nothing but rho vector, plus AP vector is nothing but my z vector. Now g vector I can write as the magnitude of g is r of cos theta. Rho vector can be written as in terms of x and y axis, so it's nothing but rho of cos phi x hat sin phi y hat and z vector. Now rho, I have already seen that rho can be given by this length, and this length is r sin theta. So rho is my r of sin theta, multiply everything r of sin theta cos phi x hat r sin theta sin phi y hat, and z vector is nothing but from here to here the length is r cos theta z hat. So this is my, now r hat can be given as r vector by r is going to give me r, so just differentiate with respect to r. Now I need to find the theta hat. Theta hat can be given as dr hat over d theta. This is my r hat. Well, differentiate it. I can write sin theta differentiate going to be cos theta cos pi x hat. Now theta hat is going to give me like this. Now what happens to rho vector? Since rho vector is given by rho of cos phi x hat of sin phi y hat, so simply rho d rho by d rho vector by rho vector gives me rho hat, and it's cos phi plus sin phi. Similarly, phi hat can be given by d rho vector over d phi, and this is going to give me minus sin phi x hat plus cos phi y hat. So I have a very beautiful result where I have figured out what's my r hat, what's my theta hat, and what is phi hat. Now I can always from here calculate what's my x and y and z hat, and from here we can easily express in terms of r, theta and phi, and we will have a very beautiful result in terms of that. If I am x vector, what's my r hat, theta hat, phi hat for y and for z also. So you see, this is a very beautiful equation, and now how this going to help me to solve the complicated problem very easily. So let me just describe about that thing. I will figure out what is my length element, area element, and dv element. You remember that if I am in Cartesian coordinate system, then I would have written that dx, dy, and dz hat. Now from the previous thing, I can easily find out what's my x, y, and z, and we can find out what is my dx, dy, and dz. Plug this into and we will find what is the length element in the polar coordinate system. And if you will do that, the same process which I have done in polar coordinate system, we will find dr r hat plus r d theta theta hat, and this will go r sin theta d phi phi hat. Now the whole x hat, y hat, and z hat has been replaced by r hat, theta hat, and phi hat, and we have found out what's my length element. So if you are having any kind of system which possesses a spherical symmetry just like this point, I can easily find what is the length element of this guy. We will use this one. Now there are so many times we have to use what is the area element. So for example, if you want to find some area on a sphere, what you're going to do is, the area is just like that. Suppose you have surface and you want to find the area. So what is the area of this guy? Well, to find the area, what we are going to use that, so area in which direction, because area is direction dependent, so you can easily use dr r d theta. Now r cross theta hat is going to give you the phi hat, so this is in a phi hat direction. Or you can use simply dA is equal to r d theta r sin theta d phi, and this is in direction of, because you are using theta cross phi is nothing but r hat. Now one more thing I am going to say that, because you can see here, if you are talking about area, what happens is that area is on the surface. Okay, now the surface, the radius is constant. So if you are having the radius is constant, so this dr term is going to vanish. What you are left with that r d theta, that is theta hat component and phi hat component. So this use of this formula is no longer very good for you. The thing you can use is that area element for this one. So you can always use dA vector is r d theta r sin theta d phi in a r hat direction. Now what you have to going to do is what happens to the volume element. So here again I am having this sphere. So what would be the volume? The volume is something like that. Okay, now the volume can be written as what's happened to r theta, and again what is the projection on this thing. So this is my phi. So we need everything. So like dv, I can use dx, dy, dg in Cartesian coordinate system. The same thing I can use here. Now here you can see the dx component gives you r, dy component gives you r d theta, and dz component gives you r sin theta d phi. Just to multiply everything, what you're going to do is dr r d theta r sin theta d phi, and now you will get is that r squared dr d theta sin theta d phi. This is one more question is that, okay, you have chosen here r, so I know the r is going from the center to the surface, that is my r. But what happens to this what happens to the angle theta? Now angle theta is only goes from this to this one. Okay, so your z axis is this one, so this longitudinal angle can go from 0 to pi. So always remember that whenever you are working on the polar coordinate system, your limit will be 0 to pi, r limit will be 0 to r, and this phi angle where we can go now this whole pi angle will be like this. So whenever you are going from here, the phi angle will round from this one. So this is the latitude angle, and it will make a very good this one, a circle type thing. Okay, so the phi will always go from 0 to 2 pi. Now you will and ask that, okay, can we derive the volume of sphere from this one? Yeah, obviously, because you can write is dv. Now integral, because you have to find out the whole volume, is nothing but r square dr. Now it will become the triple integration and d phi. Well, d phi is going to limit from 0 to 2 pi, theta is going to 0 to pi, and this guy is 0 to r. So you can now analyze it. The volume can be given as r cube by 3, because if you relate it, now sine theta is going to minus of cos theta 0 to pi, and this guy will 0 to 2 pi. R cube by 2, cos theta, cos of phi is minus 1, minus minus plus, and cos 0 is negative, so it is by negative of 1. You can figure it out. And 2 into 2 pi, that is all 4 pi, 4 by 3 pi r cube, and this is the simple volume of the sphere. So you see, you didn't have to use any kind of Cartesian coordinate system that, okay, this is my z-axis and I have to cut any kind of disk, because if you are going to use any kind of situation like you have to draw some kind of a disk here, cut a disk, take z here, now take component x square plus y square, and from there we have to use all the funny thing, and from there you will find that, okay, this is the volume of the sphere. But as we have defined what is my r hat, theta hat, and phi hat, and we have defined what's the length element, we can easily have found out what is the volume element, what is the area element, what is the length element. So this is the most important thing in this lecture, and anywhere you will encounter in physics, because in later my video I will present you too many applications how to use the spherical polar coordinate system, like in Gauss theorem, where you have to find the electric field outside the sphere, inside the sphere, on the surface of the sphere, as well as I am going to show you how will you find the area. So area is nothing but sine theta, d theta, and d phi. Well, here you have to represent it, because this is, now you can use here, this is my r, okay, r into r gives you r squared, and now r squared, because the length from here to surface is fixed, it's not changing, so I can write it as r squared, it's not changing. Now it will run from 0 to 2 pi, and this is going to run from 0 to pi. R square is fixed, r square. Now I know what this integral give me, that is 4 pi. So I am having a beautiful equation that area of sphere is 4 pi r square. So later video I will discuss about Gauss theorem. I will find out how we find the gravitational potential or gravity due to the spherical object inside as well as outside. So you will see tomorrow that how g will vary with r squared outside if r is greater than r, or at the surface, because you know g is equal to g mm by r squared. Now what happens to g is what? G is function of r inside the radius. Suppose you have a circle and you want to find what is my g is varying inside, so we will find what is the g. What happens to nucleus? Nucleus contains proton numbers, so if you are having g proton numbers, so these protons will represent. Now since it contains also neutron, but neutron has 0 charges. Now I will show you how to find the electric potential energy of the nucleus. Okay, so we are having the two mass positive charges, they will repel each other, but they again cannot escape the nucleus because of the strong nuclear forces. So we will calculate what is the electrostatic potential energy due to this proton. So suppose we are picking this proton, that is suppose z number of proton, that is 1 proton, there are rest number of proton, that is my z minus 1. So if suppose you are having a 5 protons in the nucleus, so what happens is you will pick 5 into 4, because if you are the number of protons is, that is q into q. Okay, so 1 proton if you are picking, so there are rest, the rest is this minus this one, so that's why we are going to use that electric potential energy is equal to z into z minus 1. Then what happens to function of r, what will come? So we will see that what would happen with the potential energy for the nucleus. So thank you so much.